All right, so guys, picking up where we left off, like I said on Friday, we hit on the parent functions, but now we're going to stretch this to where we want to be able to graph any sine or cosine curve. All right, so first thing that I want to get out there before I forget, we have two slides that are saying a lot of the same information. Okay, now why put it in two different ways? So it's just to kind of get out in front of that. This, what we see on this first slide. These provided equations, y equals d plus a times the sine of bx minus c, or the cosine equivalent, where they're putting d out front. That's the constant. This is the way that it's written in our textbook, and frankly in other textbooks as well. I don't know why, but textbooks always write it out this way. Then, as soon as you start to do problems or see problems, it's never written that way. So why? Yeah, so that's why we have two slides of it. This is the textbook form, but again, I just think it's stupid. Why wouldn't we put the variables in alphabetical order? I don't know, that bothers me. So luckily, this is the way that it's going to be presented the majority of the time. So I'm going to be bouncing back and forth between the two slides, but I do want you to realize that the second slide here, this is the way that it'd be inaccurate for me to say that every problem will be in this format, but the majority of the time, this is what you're looking at. Y equals a times the sine of bx minus c plus c, where a is simply the coefficient that's out in front. Okay? So again, what we had on Friday, everything was always the same. Y equals the sine of x. That's what everything looked like. So what happens if we put a number up front? Okay. Now, we talked about that. That's called amplitude, but for our first thing, but even before we get into what do they do, let's just talk about the variables. So that's what we're going to refer to as a, the coefficient that's in front of the sine or cosine, the trig function. Okay, b is going to be the coefficient that's in front of the x. So again, on Friday, every problem that we had, b was 1. There was never a number in front of the x other than 1. But what if, that could change. What if we have a 2 in front of there? Then I guess b is 2. C is the amount being subtracted. So in this case, maybe C is 5 or something like that. C is the amount being subtracted. Now, if you were to guess, what does that do? What would that do if we were talking about a parabola or something like that, and we had g of x is equal to x minus 5 squared? What would that do? Shift it to the right 5? Okay. Do we think that's going to do the same thing here? Yes, but there's a little asterisk that I'd have to put next to it. There's a little bit more to the story, but yes, I would confidently tell you that minus 5, that C value, that will factor into the horizontal movement. It's not the entire horizontal movement because B is going to mess that up a little bit, but again, we're going to talk about that here a little bit. And then finally, D, that's the constant that's being added to the entire thing. So if we had something like plus 7, if you had to guess, what do you suppose that's going to do? That's going to shift things up 7. And if that's what you're thinking, that's exactly right. Okay? So again, A is the coefficient that's out in front of the entire trig function. B is the coefficient just in front of the x. C is the amount being subtracted. We need to remember that. It's the amount being subtracted from the x. D is the constant that's all by itself that's outside of the function. Okay? So really, I would argue that the most important aspects, or at least the first important hurdle that we get over, is understanding A, B, C, and D, and being able to identify where's A, where's B, where's C, where's D, or not where, or not only where, but what are those 4 values. Because once we have those 4 values, then we're going to be able to start to answer some questions, and I think now would be the appropriate time. So A, as we've already mentioned, that's going to represent the amplitude. Now there's a little bit more to the story, specifically, thank you, that what we're going to be able to say is that the absolute value of A is going to be your amplitude. So now remember, amplitude, that's just how much we're stretching. Okay, we're gonna normally, quote unquote, normally have that again, that sine curve or that cosine curve going up 1, back down to 0, down 1, back up. That's our natural progression. But if we have an amplitude, we're going to stretch that. Okay, so on that pink worksheet that we had on Friday, I think the first problem we had an amplitude of 3, if I'm remembering correctly. So wherever we were on the parent function going up 1, now we're going up 3. Okay, where we're going down to -1, now we're going down to -3. Now, what would have happened if our amplitude was 10? Then we wouldn't have gone up 3, we would go up 10, right? So again, let's not make that harder than it needs to be. But that's amplitude. We find that by calculating the absolute value of A. Now, that means that there's no such thing as a negative amplitude. But what happens if A is negative? That's going to be a reflection. Absolutely. Just like every other parent function that we've had, if that leading coefficient out in front is negative, absolutely we're going to reflect over the x-axis. We'll talk more about that as we go. All right, so as you were walking in, a few of you, because of my oversight, it was written on the pink worksheet to identify the period. I'm not, again, don't worry about it if you didn't do that. But the way that we're going to calculate period, when we're talking about sine and cosine, it's always going to be 2 pi divided by b. So whatever that value is for b, remember b is simply the coefficient that's in front of the x. We're going to take 2 pi and divide by b. Now, today, finishing up 4.5, we're just talking about sine and cosine, so we can say that that's the only one that we need to worry about. Long term, like getting into tomorrow's stuff, in 4.6, when we're going to be graphing the others. So again, today sine and cosine. Tomorrow we're going to graph secant, cosecant, tangent, cotangent. It's going to start to change a little bit. The period is still going to be 2 pi over b if we're talking about secant and cosecant, but tangent and cotangent, that period is going to be altered. And we'll talk about the reasons why tomorrow. Okay, but just kind of a heads up on that. All right, now what we refer to as the phase shift. Now, we're going to talk about this in terms of the framing method. So again, some of this terminology may be a little bit off. But again, phase shift, all that we're talking about, how much are you moving side to side? Now, the way that we're doing this is that we actually are going to be moving C over B. So whatever our value is for C divided by whatever our value is for B. Okay, so again, we have to factor in C divided by B. That's going to tell us how much we're moving to the left or to the right. Again, if that seems a little weird, just trust me, we have a better way of talking about this real soon. And then our vertical displacement, our vertical shifting up or down, exactly as it has been for every other parent function. It's just whatever your constant is. For that red function that we wrote up there, that red one, again, we had +7 at the end. That would absolutely indicate that you're moving up 7. As far as the phase shift goes here, looks like C is 5 divided by B is 2. Looks like we're going over 5 halves. We're going over 2.5. Okay? So we got a lot more to come on that. Now here, hopefully you view this as good news just like I do. The whole idea of A, B, C, and D, the whole idea of how to find the amplitude period, and then our shifting side to side or up and down, it doesn't matter if it's a sine function or a cosine function, they work identically. Okay? They're the exact same. All right, so let's go back to that previous slide. A lot of the same information, I'm going to warn you, but again, it's just different format as far as what it's going to look like. Remember, D, that's going to translate the graph up or down. We're going to be shifting it up. We're going to be shifting it down. A is going to be the amplitude. Technically, it's the absolute value of A. I would encourage you to add that. So the absolute value of A is the amplitude. Vertically stretches or shrinks the graph. The constant C, that's going to help translate the graph horizontally. So again, this is the first thing that I would encourage you to highlight. 2 pi over B, that's the period. Now, understand the period, what that means. That's going to be the interval required to complete one full sine or cosine cycle. So that means when you start at 0 and you go all the way around at 2 pi, you get back to where you started, that represents one period. So what if we started at 0 and then we went around to 4 pi? Well, that means that we went around once, we went around again, that'd be 2 periods. Okay, if we went around 3 times, we went from 0 around to 6 pi. That'd be 3 periods, and hopefully we're understanding how this works. Now, what we can do, as weird as this may sound, give you a chance to sketch this up here. Everything was always in terms of, so like I over 2 pi, 3 pi over 2, 2 pi. We were talking about, and then kept going 1 to -1. So on a sine curve, we were hitting these points. So those are the points that we were hitting. And that would represent, as normal, again, I should probably identify that this is y equals sine of x, that the period in this case was 2 pi. Now, what did we add in today? What did we say? How do you find period? What is that? 2 pi divided by b. Well, what was b in this parent function? It's just 1, right? So what's 2 pi divided by 1? Still 2 pi, okay? Now, what if we did this? What if we said y equals the sine of 2x? Now, that changes some things. Now, when we go to find the period, remember how we calculate periods? We take 2 pi, we divide by b. Well, in this case, what is b? Well, now b is 2. 2 pi divided by 2 is just going to be pi. So what that means is that our entire cycle, to where we start, we go up, come back down through, and go back up. So again, intercept, maximum, intercept, minimum, intercept. That has to happen completely before we get to pi. Does that make sense? So that means that we're going to start here, but I'm going to have intercepts and maximums now looking like this. You see the difference? All that we're doing basically is horizontally, we're shrinking that down. We're saying that we have to do that one loop, we have to do that one trip all the way through, but it has to happen by this point. Okay? Could we stretch that out? Like, what if we had here, what if we had y equals the sine of 1/2 x? Well, now, how do you find period again? 2 pi divided by b. In this case, b is 1/2. Okay, you're probably tired of me asking, but what do you do when you divide fractions? Multiply by the reciprocal. So this is going to really start to look like 2 pi times 2 over 1. Quickly, we're going to realize that period is going to be 4 pi. So, again, I didn't leave myself enough space, but now we're going to be hitting these points. Okay, so as you can see, this giant mess that I'm making, we could alter the way that this looks dramatically just by having a number in front of that x. Okay, so that b value. So the good news, if this is starting to seem a little overwhelming, the good news is that real soon we're going to start talking about this framing method, and basically what the one frame is going to represent is one period. And if you can draw within that frame, it's going to be super easy. Hopefully, that's the goal anyway. All right, so a couple of other things to point out here on this slide. Just wanting to note that the amplitude, A, that's going to lead to the range of the function. So again, all of these that I drew down here, they were going up and down 1 unit. So if the amplitude was 5, they go up 5, down 5. Okay. If the amplitude is always going to be positive, but if A is negative, then that's when we're going to do our reflection. So guys, this next point, and this next part, I would encourage you to highlight this, know what's going on here. This is going to be a big deal for us. Instead of thinking about moving, all right, I have my entire sine function, and I have to move it to the left this much, and then I have to move it up this much. What we're going to do is we're going to create a starting point. Okay, now, I definitely want to stress this, that this is not the starting point of our graph. This is the starting point of our frame that we're going to build. And I know that we haven't actually done that yet, but again, that's going to be the starting point for the frame. All that we're doing, another way that we could call this, and I would encourage you to write this down, this is going to be the new origin. That's what the starting point is to really be. Is we're taking the origin, which obviously is at 0, 0, and we're going to say, yeah, we're going to move that to be at c over b comma d. Because c over b, remember, that represents horizontal movement, d represents vertical movement. So if you're moving left pi up 7, then wouldn't your origin move to negative pi comma 7? That's what c over b comma d, that's as a starting point, that's what it represents. Hopefully I've built up enough rapport with you throughout first semester and the first few weeks of this semester to where you just trust me. Trust me on this one. It's so much easier if we don't think about it in terms of horizontal and vertical shifting. Instead, we think of it as, all right, where am I going to put that origin? All right, where does that origin go? This is, okay, my new starting point, c over b comma d, that's where it is. All right, then the last thing we want to point out, we already kind of had this little discussion down here, that if b gets larger, the period decreases. If b gets smaller, that's when the period is going to elongate or stretch. All right? Okay, so feeling pretty good about these first 2 slides? All right, all right. don't like that anymore.